Greetings, everybody. My name is Jose Gomez, and I am a two-year student at SPVC, and my intended major is for aerospace engineering. I hope to transfer to Cal Poly Pomona in the fall.
Good morning. My name is Luis Rosales. I am a computer engineering major. I've been here at SPVC for 2 years. I'm coming up on my last terms. And I wish to transfer to University of California, Riverside.
Hello, my name is Mary Logan. I've been at San Bernardino Valley College for 2 years. I just graduated with a physics degree and hopes to pursue an astrophysics degree.
So today we are going to be talking to you about our space cave exploration project that we worked on this summer. So just to tell you a little bit about our project, it is a project intended to build a rover for Mars. Where our inspiration came from, we were inspired by the Mars explorations, and we were looking for ways that we could kind of build a project that would help someday colonize Mars. And we were looking at obstacles that we face in Mars, and one of them being cosmic rays and radiations. So we were looking at ways that we could use a rover to help us plan for the future. So we were looking at caves and lava tunnels in Mars. So we decided that we wanted to build a rover that would be capable of exploring these caves autonomously and map them using LiDAR. So what we wanted to do is plan for structures that can be built, and with the information that we received from the mapping, this would help with coming up with a plan to further Mars colonization and habitats.
Another thing that we were looking for would be using the rovers as rescue missions. In Mars, there will be limited personnel, and a lot of the life will be underground. So a lot of caves will be very dark. So the rover itself does not need any light, it just needs the LiDAR. So if somebody, say for example, was trapped in a cave and there was some kind of demolition in the cave, then we would be able to send the rover down there. A few of the challenges that we faced when designing the rover was, at first we wanted to create some kind of flying drone. However, the flying drone would not be able to handle all the weight that we wanted it to handle, all the electronics. So we decided that to take that variable out, we would go ahead and create a rover instead. So right now our rover just has a LiDAR, and has an Arduino, and it also has a power bank. The LiDAR is connected to a small motor that when the rover moves, it will look around, see what the best path is, and then move forward.
Obstacles and perseverance. So we came across a few obstacles along the way, the main one being we lost one of our key partners a good portion of the way through. And it took us a long time to receive the robot kit. So we did a lot of brainstorming before we knew exactly what tools we were working with. And we all had different ideas. As he mentioned, we decided on a drone initially, and we came across so many issues with that we just decided to do the rover. But even the rover had many different ways to build it. So we had a learning curve with the robotics, the programming, and the mapping software. But overall, we did found it beneficial to work together as a team and meet our differences in the middle and create something that we could all be proud of. So for our next steps, we would like to add a LED light as an incoming radiation sensor, develop a chassis and a solar panel just on the model itself. We would like to program it with algorithms to keep it moving, mapping out terrain and extract data for deep subterranean environments. And add a heat shield, a radiation shield, using high-density polyethylene, and parallel it to a functioning model, like an upscaled version of it, to determine the materials for each part and sustainability for an actual Mars mission. That would include a gyroscope to prevent rolling over, line tracking sensors to prevent it falling off cliffs, traction and radio signals in the upscaled version. And that's just some of the things we'd like to add. This is the ideal outcome for an actual Mars rover. It has a computer, a gyroscope, solar panels, the LiDAR scanner, a communication antenna, a radiation shield, rechargeable pack, and navigation cameras. So hopefully this would go on Mars and enter the caves.
So that is, in a nutshell, our project that we worked on this summer. It is at a very early stage, and we hope to continue to develop this project further. I know we will be handing over this idea to our robotics club this fall, and we hope that we are able to continue to work on rover technology to help us achieve our goal and our idea for Mars space exploration.
And we'll demonstrate our rover right now.
We're going to demonstrate.
He's always there all day.
So we're using ultrasonic sensors to detect obstacles. That's pretty much it. I don't even know Is it recording? Yeah.